So for example, one thing that we often need to do is to recode variables or compute variables. So you can use R like a regular calculator, but that is not so interesting here. What is more interesting is how you can manipulate the data set. And this combination, this line here, you're going to see a few times now. That is kind of, it's very confusing, but kind of important to understand a little bit what this means. So this assumes that the data set is here, it's called data. Yeah. So however you called it, when you when you use the import command, whatever name you gave to it, that's the name that goes there. And this says, through the data objects, we save, this is to save information to a particular object, this arrow. Yeah. And what we save is we take the data as we have it, and we pass it on. So this is to pass it on. We pass it on to the mutate command. Yeah, so that's basically what this says. So this take the data object is what happens here. The pass it to mutate is what happens here. The computations happen here, and then it gets saved here. And then you can calculate any variables you might want to compute. So here, for example, the new variable age is created because there was a birth year in the data set, but not age. We know that the survey took place in 2017. So we can calculate age as 2017 minus birth year. Yeah. Or if we want age squared, we can take the age variable and we can square it. Yeah. So any kind of computation you want to do. This is actually the difficult part. The computation is often the easier part, but it's that first that is a bit confusing. So that is how to mutate variables, and we can also do other kinds of calculations. So we can use functions inside there. We can use functions like the logarithm, for example. Yeah. So often when we have money variables like GDP per capita, or we have or income, but also things like population size, they tend to have a distribution that looks a bit like this. A lot of countries at the low end, and then some countries extremely rich or extremely large. Yeah. So GDP will always have a distribution like this, with many countries on the left and then few countries on the right. And this skews all the plots you make and regressions you run, etc. If you take the log, this will start to look more like this. Yeah? It will stretch out this part and it will squeeze this part. Yeah, and the result is something that is much easier to visualize, to run regressions with, etc. There are more theoretical reasons behind doing that economists will be aware of. But for very pragmatic purposes, it just makes all the plots more readable and regressions work better. We take the data object, we pass it to mutate, we then compute some variables, and then we save it as the new data object. Now, this is more for your reference than anything. But there are these comparisons. If you want to separate two groups, for example, take all the countries that have a democracy scored and greater than 6, for example, or take all the respondents who are less than 40 years old, or this kind of questions. Then we have these comparators, and most of them are probably relatively obvious. But beware of this one, that confuses a lot of beginner programmers, computer users. So 1 = sign means assignment, like here, that the new young variable is all of this. 2 = means to compare for equality. Yeah. So if I want to say is A equal to B, I need to do 2 =. If I want to say A should be the same as B, then I use 1 =. Yeah? So if I type A = 2, I set A equal to 2. If I say this one is either true or false, depending on whether A is equal to 2. Yeah, so the first one sets A equal to 2, and the second one compares A to 2. And not equal might also be a little bit confusing. So this exclamation mark here means not. Yeah. And then here, I don't want you to worry too much about this part, but you have the if-else here that compares a condition, and then this is if it's true, and this is if it's false. So this young becomes a variable with 2 categories, young and old. And it's young when age is less than 41 and old when it's greater than 41. I clearly have not updated my slides in the last 5 years. I would never say this out loud anymore. Now, this one is just for your reference. I'm not going to discuss now, but when you Sometimes you want to have combinations, right? So you want to call somebody middle age when they are between 41 and 55, or you want to say a country should be democratic and wealthy, or etc. So then you can use and and or. And in R, that means a vertical line or the ampersand. Yeah, and then you can combine them. And that's not too important right now, so I'll pass that. This is very important. And I think some of you have done this already. Some groups have been doing this for the slides already, which was very nice. So sometimes in this mutate command that I just mentioned, so this is the mutate command that we use to compute variables. We also have the recode function. And what recode does is to take a set of old categories and put them in a set of new categories. Yeah. So you can take the variable Q41 here, which has 5 different values. It's a Likert scale from strongly agree to strongly disagree. And maybe we want to have a 3-point scale instead. So we can say the old value 1 should become the new value 1, the old value 2 should become the new value 2, the old value 5 should become the new value 5. And then the default value, if it's not 1, 2, 3, 4, 5, should be missing, NA. So that means that we create a new variable called abolish Senate that takes the old variable Q41 and remaps 1 to 5 to 1 to 3. You saw already that this can be very useful when making graphs. Yeah, the many categories, the graphs became hard to read. With 2 or 3 categories, graphs become easier to read. In the video, we will also talk about dummy variables. For example, you can take this as 1 and this as 0, then you have only 2 categories left. And then you can use it as a dummy variable in your regression. Yeah, so regressions are only for scale variables, not for categorical variables, but there is one exception. If the variable is a dummy variable and only has the values 1 and 0, then it is a categorical variable, but it can be added to a regression. So if you have a categorical variable like this with 5 values that we cannot add to a regression, we can recode it and say this is 1 and this is 0, and then we have a binary variable and that says agree or not, and then we can add it to our regression. So we need recode quite often. Now here I use new numerical values, so we map 1 to 5 to 1 to 3. It might be more helpful to give labels like agree, neutral, disagree, makes all your plots much more readable, for example. So this is probably a bit more helpful. One thing you should always do whenever you do any recode of a variable. So one thing that is important here in this recoding is that these 2 names are not the same. So this is a new name for an old name. Yeah, you can make them the same and then you overwrite the old variable, but then the next slide doesn't work anymore. Yeah, so it's a better idea to always have a new name. And the advantage of having a new name is that you can then make a table of the 2. Yeah? So here you make a table comparing the old and the new values. And then you can see whether the recoding works the way you thought it works or not. Yeah. And you should also always add this exclude equals 0, which means that all the missing data is still included in the table. And you can see that the coding worked correctly even where it was missing. Yeah. So very important, whenever you do a recode, always make a habit of then also do the associated table. Probably the trickiest part I want to explain here, but the one that you will use less in this. So recoding you will see quite a bit throughout now the course, so it helps to understand. Merging you will do less often, but if you are starting to do your own analysis at some point, you quite often do merge. Yeah. So merge is when you have different data sets that are about the same objects and you want to combine them so that you can do analysis. So for example, we might have them at different levels. We might have a data set on candidates and a data set on electoral districts. Or we might have different data sets on countries, for example. We might have from the World Bank, we can get some economic data. And then from, what is it called? Correlates of War project, we get data on conflict. And from polity data, we get data on democracy and autocracy. And maybe we want to look at the relationship between conflict and economics and political systems. So then you need to somehow merge those. You need to make sure that when data is on the same country in the same year, that they are mapped onto each other correctly. And that is merging data. So here's an example. we might have two data sets, one that has data on the districts. So this is district magnitude, how many seats are in each district. This is how many total votes there are in the district, the name of the district. And then we have another data set that is about candidates. We have the party of the candidate, the name of the candidate, the number of votes they obtained. And of course, if you want to merge, you need at least one variable in common to merge on, right? So the thing where they match here is this variable. District here matches on district here. Yeah. So it has to be the same spelling, the same contents. Yeah. Otherwise, it doesn't work. And then we can merge the two data sets. We can merge them so that it becomes one data set that still has all the candidates, but that now also has the data on the districts merged. Yeah, and you will see that it will start repeating, of course, information because there are multiple candidates in the one district. But you get one data set with all the candidates, but that includes variables that are at the level of the constituency or the district, not at the level of the candidate. Yeah. And to do this, we need to, these names need to exactly match, otherwise it's not going to work. Yeah. So that is what is meant by merging, and it happens frequently. Now, sometimes there are challenges like, you know, you download one data set and they talk about Korea, South, and you download another data set and it talks about South Korea. And you want to merge those two data sets, and of course it can't find the matching country, right? This happens often, unfortunately. I once helped somebody merging data on African villages, then it becomes far, far, far worse. But even with national country data, this happens a lot, and this kind of problems happen a lot. So sometimes you need to recode a little bit, change some of the labels of some of the countries, say, before you can merge, just to match them. So you need to be very careful. You can't just type merge and hope that everything works. You need to look very carefully whether you're missing any mismatches, sorry, or spelling confusion. You will see this problem in the lab. Côte d'Ivoire or Ivory Coast is always one that creates problems with them. Yeah, so this is the basic command, merge. Then you have so this is the name of the first data set, the name of the second data set, the variable name that they should have in common. And this says that to include all the observations, even if a district is missing in the candidates data set or a candidate is missing in the district. Yeah? So it merges everything.